Hello, in this lesson I want you to identify the end behavior of graphs, and I want you to identify extrema of functions. Some vocabulary you're going to come across are end behavior, relative maximum, relative minimum, turning point, and extrema. We'll start here. The end behavior of a function is what happens as x gets really, really big or x gets really, really negative. If you have a polynomial function and it's an even degree and the leading coefficient is positive, as x gets towards positive infinity or negative infinity, your function f of x is going to go towards positive infinity. If you have an even degree with a negative leading coefficient, as x gets really, really big, positive or negative, towards infinity, your graph is going to approach negative infinity. If you have an odd function of odd power with a leading coefficient of an odd degree, and it's positive, as x approaches positive infinity, your graph is going to approach positive infinity. As x approaches negative infinity, your graph is going to approach negative infinity. And it's just the opposite if you have a negative leading coefficient. That is, if x approaches positive infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x is going to approach positive infinity. But really, all you got to do is you got to notice the pattern, what's going on. So let's take a look at a couple examples here. And we'll also learn how to write this. Here we have a linear function. Notice, as x approaches positive infinity, your function f of x is also approaching positive infinity, isn't it? And as x approaches negative infinity, as x gets really, really big, f of x is going to approach negative infinity. Because you can see the graph is going down as it goes to the left. Here's a good example of one that doesn't approach infinity. Notice y is always negative 1.5. So I can say as x approaches positive or negative infinity, doesn't matter which direction, f of x is going to equal to negative 1.5. It's always going to be negative 1.5. It doesn't change. Here we have an even polynomial because we notice the end behavior goes in the same direction. So I'm going to say as x approaches positive or negative infinity, what's happened to your graph? Well, f of x is going to be approaching negative infinity. Here we have an odd polynomial. So we're going to have to write it twice. As x approaches positive infinity, well, as you go to the right, the graph is getting higher, isn't it? So f of x is going to approach positive infinity. As x approaches negative infinity, f of x is going down, so it's going to approach negative infinity.